So before the slides will appear, my name is Mihai Fecero. I'm an engineering manager at Adobe. I'm running several projects. What I would like to do in like 10 minutes or so is to present one of the projects that happen in my group, just to give you a flavor on the type of projects involve Java that we are doing here in Romania. So the project is called Audience Manager. That's a picture of New York. That half of the TV is in Romania, half of the TV is in New York, and that was an opportunity for me to visit Manhattan. Let me see. Okay, so first of all, what's Audience Manager? I'm going to give you an idea on the project, just to see how simple a problem might be, and then we'll go to really understand how complex that problem really is, in fact. So Audience Manager is solving a relatively simple, or maybe probably a simple problem, which is we are gathering information about users that are visiting digital properties of our customers, right? So our customers have like websites or mobile applications, and they want to know as much information as possible about the users that are visiting those digital properties. And how things are working, basically here you have someone that is using their desktop to visit mtv.com. This is one of our customers. And what's happening, very simply, is we have an HTTP call that comes to our servers that contain several information, nothing more than key value pairs. And what we are returning is a list of segments. Okay, so this device, this user qualifies for these two segments, interested in rock music and he's living in Bucharest. And you can imagine that here you have a JavaScript code that is using this information to personalize, right, this website, right? You can have a rock guitar that appears in that website. Another use case is MTV would like us to send this information, interested in rock concerts in Bucharest, to a demand-side platform, so a solution that is helping MTV to place ads on their site. And then when there is an opportunity for an ad to show on their site, MTV site will make a request to a demand-side platform asking for an ad. And this ad platform know, okay, I'm dealing with someone that is interested in a rock concert and he's living in Bucharest, so I'm gonna, serve this ad. Queen is coming in Bucharest in about 2 weeks, which is a great thing, right? So again, even if we are in advertising, online advertising business, we are not actually doing advertising. We are helping our partners to find out information about the users in order to personalize their sites or to put ads, right? So how hard this problem can be, right? I'm just gathering information about users and sharing them. Well, it turns out it's not that simple. That's I'm calling it a scary diagram. That's the first thing. I joined this product like 3 years ago. And after like 6 months, I was not able to really grasp all the components from this product. So the first thing that I've done was try to put them all in a single page. So I'm not going to go through this diagram, but that's just an idea on. Please don't make pictures. That's how things are looking like, right? So if you are going to look how this system looks like, basically everything is, first of all, everything is placed in Amazon, right? So this is a deployment in Amazon. It's a huge deployment in Amazon. It is one of the biggest deployment in Amazon in the world. We have like more than 1,000 nodes for this project. This project has basically 4 areas. The first part is what we are calling edge. In this part, we are collecting those HTTP codes that you have seen in the previous slide, right? We are collecting the information, and this edge is basically these are Java applications. These are clusters of Java applications that are collecting those HTTP calls and are putting them in some cache implementation, and we are using Cassandra for this. The second part is a central processing cluster where we are merging all the profiles from the edges. And that's a Hadoop HBase cluster that has like right now 400 nodes that are constantly merging all this information. The third one is an analytics cluster that provides some analytics information and then an API part, right? So everything here is like a deployment of 1,000 nodes. So that's how complex such a deployment can be. So last thing, just wanted to, my goal was to present you an apparently simple problem, show you how complex that problem can be if you wanted to solve it at a large scale. And then I wanted to kind of go with you through, the challenges that we have with this. One may have with operating such a big solution. So first is it's a service, right? It has to be up and running all the time. The SLA that we have, the service level agreement that we have is 3.9. And if you look at what 3.9 means the service is allowed to be down for about 44 minutes per month. And that's, that's a bit scary. So in order to achieve this, we have redundancy at all the levels, like web-based, web application, database, and so on, monitoring, alerting system, and all the stuff. The second thing, everything that we need to build, yeah, it's Java, but all the applications that we need to build, we need to make sure that this is scalable. Scalable for us means if tomorrow the size of the data will be 10 to 10 times larger or even 100 times larger, the answer from our side should be, okay, no problem, we'll just increase the infrastructure 10 times or 100 times and we can do it, right? This is called horizontal scaling. And that's not an easy thing to do. Another thing is, okay, we have endpoints that are exposed to internet. We need to make sure that any types of, DOS attacks or incorrect service usage, we are prepared for this. It's a cool thing in Amazon that if you use Amazon, you have this auto scale thing that can be used for these type of things. Infrastructure management. Imagine that when you have an infrastructure of about 1,000 nodes, deploying them manually, it's no good. So you have to automate everything that's related to infrastructure management, to list management, and so on. Open source technologies. We are using huge amount of open source technologies from HBase to Hive to Solar to Cassandra and so on. And it's not enough to just use those technologies. You have to understand them, and you should be able to understand them because it's open source. The code is there, and then you are you have to understand them because if you have any issues, you have to fix them and you have to contribute back to the community. And obviously, you have to understand the business ecosystem, which is the online advertising space. It's quite complex. That's about it. I hope that I fit into the 10 minutes. I don't know. Any questions?
Yep. What are you using for horizontal scaling? So maybe are you using some configuration management tool? Which one?
No. For horizontal scaling, we are using, or we plan to use right now. It's the methodology that we are using is we simply have the edge part over provisioned. But what we are working on right now is to use the AWS auto scaling capability, which is, so AWS allows you to create a set of signals and define some thresholds. And whenever those thresholds are being met, for example, some thresholds may be the CPU utilization on some nodes is over a certain value, or the memory is over a certain value, and so on. You can basically create new nodes on the web service, for example, to handle the traffic that is coming. Right. So that's basically the way it's being handled. Yep. That's how it's done. Yep.
So the incorrect service usage, what may that not imply?
Well, that's exactly what happened to us like 1 year ago. There was one customer that had an incorrect implementation on their website, so they started to, there was, we are making a difference between those attacks and incorrect service. The net effect for us, it's the same, right? We are receiving huge amount of HTTP calls, right? And we are not provisioned for that. But those attacks is something that is doing that attack with to us as a mean person. However, incorrect service usage is just, our customer has an incorrect bug in their site implementation, and without any, bad intention, they are doing a lot of HTTP calls to us, right? We had such a customer. When you are dealing with huge customers that have big, really big website implementations, any issue on their side may result on a huge amount of HTTP calls on our side. And if we are not prepared, and 1 year ago we were not prepared for that, you could have one data center go down. And that's what happened last year for us. Like for 3 years we were down for 3 hours we were down. We were not able to handle the traffic. Okay, anything else? Thanks. Thank you.
So thank you. Patrick will continue. Okay. Patrick, you have the seat.
Okay. All right. I'm Patrick Curran. I'm chair of the Java Community Process Organization. I want to welcome you here and say thank you for inviting me to talk to you. I'm actually in town because Oracle pays my salary, but I don't think of myself as an Oracle. It's not my job to sell products. It's my job to represent the interests of the Java community and developers yourselves to Oracle. And I spend more time kind of pushing Oracle than I do pushing their products, if you see what I mean. But they hold every year, they have a whole bunch of user groups, not just Java user groups, but also Oracle product user groups. They hold meetings. I was at one in Shanghai for the Far East a few weeks ago, where they bring in user group leaders from the region, and they get together and they talk about stuff and so on. So I was in Shanghai recently. I'm here for the European event, which just finished yesterday. In 2 weeks' time, I'm going to Sao Paulo, Brazil, for the Latin America version of this, and there will also be one in North America. So let me switch for a second here. I want to out of full screen mode, and there is my cursor. Okay, so I want to welcome you guys as the very latest member of the JCP. Alex was actually downstairs at my hotel waiting to pick me up, and I just thought, okay, let me check my mail one last time. And just a few weeks ago, thanks to Adobe Sign, which is a wonderful electronic signature product. In the old days, when somebody wanted to join the JCP, you had to download a PDF file. You had to print out the signature page. You had to sign the signature page. Then you had to scan that page. Then you had to insert that page back into the PDF file, which unless you pay Adobe money, it's not easy to actually do that, the freebie PDF products. And then you would email that to us, and then it would come to me, and then I would have to print out that same page. I would sign it. I would reinsert it into the thing, blah, 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 blah. And now what happens is I get an email that says, we have a new agreement. Click here. I click here. It takes me to an electronic version of the agreement. There are just 2 fields that I have to fill in. You see it here. Oops, here and here. My title and my name, and I hit boom, and it's done. So literally, as Alex was downstairs, I signed it, and you got a notification like within moments. Yeah. So I recommend it. And anyway, so yeah, you are the latest member of the JCP. And in fact, since we introduced this, we only did it a few weeks ago, I've signed probably 30 or 40 new agreements. So making this a process where people can just go online instead of going through all that nonsense has actually made it much easier for us to recruit people. So I'm impressed. Okay, back to my presentation. Okay, so let me put it in full screen mode. Full screen. I don't want to stand behind this stuff. Just to see if I can. Yeah, I can. Okay. So I'm going to talk about why standards are important, how we create standards for Java, how we have been changing the JCP over the last few years, and how you can get involved in the work that we do. Standards, first of all. Nothing that exists in the world today would exist if it was not standards. Airline systems and traffic and food and drugs and safety and the way things plug into each other, and it just, well, the fact that I was able to walk into this room with this computer and within 30 seconds, okay, we're up and running and we're displaying stuff on the screen is only possible because the interfaces between the VGA output and the plugs and so on are all well defined. So that's what standards are about. And there's more than 400 standard setting organizations in the world. Some of them, many of them, I'm sure you recognize W3C, IETF, and so on, OASIS, and the JCP, ISO. Okay, so what do we mean by a standard? Informally, it's just an agreement between people that if we do things in a certain way, we'll actually do them more efficiently or more effectively than if we didn't agree on how we did stuff. More formally, the assumption is that there's some kind of documented process, which was developed through some kind of formal process, and that defines rules or guidelines or ways of doing something for the same purpose, for making it more effective. I don't know if you know who this is, Huja. My wife happens to be too. Oh, she back up. I missed the other stuff. Yeah, okay. So my family comes from Ireland. I was born in England. I live in the United States, and I'm married to a lady, Turkish one. So I'm all kind of jumbled up. And the result is I love to travel, so I'm really glad to be here. And I travel as much as I can. In Turkey, Hoca is very well known. Does anyone know who he is? You know the man? Okay. So Hoca was a wise man or a wise fool, depending on how you look at it. He's throughout the Middle East. He's well known. There are lots of stories about him. I'll tell this particular one. So he goes to this place and he asked somebody. He said, "Oh, somebody asked him, what time is it?" And Hoca says, "I don't know. I'm not from this place." It sounds like it's kind of a silly thing to say, but as I will say later, time and the standardization of time is something that was actually didn't happen until quite late. In fact, it didn't happen until railways came. Before the introduction of the railway, every village or town had its own separate time. Basically, typically in Europe anyway, they would have, there'd be a church or whatever. And when the sun was directly ahead, that was noon. And if you go 17 miles east or west, then you have 1 minute difference. Okay? In the days when people traveled by horseback, that really didn't matter because you couldn't do more than 50 miles, 7 kilometers or so in a day. So if the time was off by a couple of minutes, it really didn't matter. But when they introduced railways, and suddenly you were traveling maybe 100, 200, 300 miles a day, it did matter. And when the railways were first introduced in England, they had no agreement on how to construct the timetable. The timetables were really crazy because you could never tell whether the time listed for a particular station along the road was the local time, the time at the origin, or the time at the destination. Of course, if you only went north-south, it wouldn't matter. Going east-west, of course, was a big deal. So it didn't take them long to realize if we don't standardize on time, we can't run this railway. So Hoca sounds like he's very simple, but in fact, that was a wise statement. Another of my favorite stories of his. So his neighbor comes to him. Let me make sure I get this right. He goes to the neighbor and he says, "Could I borrow a big pot from you? I need to cook something. My wife needs to cook something." The neighbor says, "Sure, of course." And so Hoca does his thing, and then a couple of days later, he gives the pot back to his neighbor. And inside the big pot is a little pot. The neighbor says, "Hey, what is this? This." And Hoca says, "Okay, don't worry about it. The pot had a baby." And the neighbor says, "Oh, okay, thank you very much." And then a week or two later, Hoca goes to the neighbor and he borrows a pot. And 2 days, 3 days, 4 days, he doesn't return it. And eventually the neighbor goes and knocks on Hoja's door and says, Hoja, where's my pot? And Hoja says, oh, I'm terribly sorry, it died. And the neighbor says, what are you talking about? Pots don't die. And he said, well, you were perfectly willing to agree that pots could have a baby, so you must agree that pots can also die. Okay, that's just I put this in because I was in Turkey a few weeks ago and I thought I've always wanted to put Hoja into one of my presentations, so that was my excuse. Okay, back to more boring stuff, standards. Okay, so two kinds of standards. One addresses quality, basically. And you see that most prominently in health and safety. So you want to make sure, I understand this is an earthquake region. I live in California, basically on the San Andreas Fault. So one day I'm going to get swallowed up. So you want to have standards to make sure that the buildings you put up will stand up to whatever. You want to make sure that the cars you ride in are safe, the food and the drugs are not adulterated, and so on. So typically governments have quality standards and measurements to make sure that things, processes, typically physical things, are up to scratch. Second kind of standard, which is probably more applicable to our world, the IT world, it focuses on compatibility and interoperability. So on the hardware level, I already mentioned, we can plug all this stuff together because we have agreement on how the plugs and the sockets and the wiring and the voltages and the signals, what they all mean. The software level, we want to make sure that the programs that we write run on different systems and that computers can exchange information with each other. So this comes down basically to languages and protocols. This is the Tower of Babel. In the Christian Bible, they tell the story of way back in the old days, the human race was like one big happy family, and they, for some reason, decided they were going to build this big old tower. It's going to go all the way up to heaven. And they got so far, and then God said, you know, I don't want you doing this. This is my territory. You don't belong here. So I'm going to punish you. So he kind of, he destroyed their tower, but he punished them by dividing them to groups of people who were no longer speaking the same language. Before that, they all spoke the same language. Afterwards, they were all speaking different languages, and they could no longer communicate with each other. So languages and protocols, a common way of communicating, is probably the most fundamental form of standard. In fact, human language is the very original standard. We have to agree on what a grunt means or what a word means, you know. Otherwise, we're just not going to be able to create a community and a civilization. Interfaces, of course, refers to the way software components talk to each other. I'm coming up to 35 years in the software business, and when I started, there was no such thing as libraries. I started on very small single-board computers and the very first PCs, and wrote an assembly language. And if I wanted to read from the keyboard, the only way to do that was to go look into physical memory. You would monitor a particular location, and you would grab the value there, and you would then look it up in a lookup table and say, oh, that means the user pressed a C key. So there was no notion of anything more complex than that. My first job was, in fact, writing routines to basically libraries to do that kind of stuff, so that from assembly language you could say, okay, did the user enter a string of data, and if so, was it, or whatever. Today, of course, you can pull this stuff down off the net, and you can, you know, if they're reasonably well documented, you plug them together, and hopefully they work. But that's only possible if you standardize and define the interfaces between these components. Another way to look at this is to distinguish between de facto and de jure standards. That's Latin, but de facto means it becomes a default way of doing something because a particular product comes out in the market. I didn't put this in because I was at Adobe, because I always use this example. But PDF was originally a de facto standard. It was just a very effective way of defining the content of something that you could reproduce reliably, something that looked like a printed page. Later they did formally standardize it, but originally it was just everybody used it because it worked and it was really good. Windows is similarly not an anyway standard, but a de facto standard. De jure standards are developed through a more formal process and may or may not have support. So where did they come from? We have two kinds of standards developing or standards setting organizations. SDOs or SSOs, it's the same thing. So first off, they're national and international bodies. You'll recognize these: ANSI, ITU. ITU, by the way, International Telecommunications Union. That was the first international standards organization in the world. Originally stood for International Telegraphic. And you've probably heard the term network effect, you know. Telephones, let's take the example of telephones. When the telephone was first introduced, the question is, why would I buy a telephone if nobody else has one? Because, you know, there's nobody for me to call. So you have a network effect when it is possible to communicate with somebody else, and the more there are that combine, the more interesting the whole process becomes. But it only works if you have agreement between, for example, the different telephone companies on how they exchange information. If every telephone company manufacturer used a different code and a different mechanism, then, you know, things just wouldn't work. So the ITU was originally about the telegraph, but these days defines all sorts of electronic protocols. So these things are national and international bodies, which means that there is basically a representative from every country in the world, almost every country. And they're very, very political, and they're very slow, but they define really important stuff. But because they're so slow, in our business, people said we need some other way of doing things. We need something more nimble, more agile. So the notion of a consortium was formed, which is basically a bunch of companies typically will get together, and they will work on standardizing something, defining, take Bluetooth, for example. That's something that came out of consortium, or Ethernet, or whatever. It's a matter of a bunch of companies say, it's in our interest to define a standard way of doing whatever. Because even though we're competitors, going back to the telephone example, if we all do our own thing, then we fragment the market and, you know, nobody wins. But if we get together and we agree on how we're going to do something, then we all win because we build a much bigger market. It's a bigger share. And even though we're still competitors, we're competing for a much bigger market than otherwise there would be. So these consortiums are much more agile than the formal standards bodies. And they do often things that originate in consortiums end up going through the formal national or international process and become international standards. Another way of looking at things, okay, open standard. An open standard is basically a standard developed through a formal, documented, open, collaborative process. So there should be no barriers to participation. Everybody should be free to participate. And by the way, most standards developing organizations don't actually allow individuals to participate. We do in the JCP, but most don't. So I think we, in that sense, are more open than others. There should be a level playing field. Nobody should be favored over anybody else. The way the organization functions and does its work should be well documented, formally documented. And there should be no barriers to implementation. Everybody should be free to implement a standard. If all these criteria are met, you can say you have an open standard. Otherwise, what you have is something that's more closed and more proprietary, and there's more risk. The term open source, obviously, we're all familiar with that. So some people say, well, we don't really need standards if you've got open source. As long as you've got the source code, that's all you need. I don't believe that's true. Open source software, if it's not implementing a standard, I don't believe is very different from proprietary software. Yes, you have access to the source code. And so, yes, in theory, you can fix your own bugs. In theory, you can fork it. But in practice, unless you are a super big organization with lots of money to burn, you're locked in the same way as you are with proprietary stuff. You're dependent on the people that create this particular library or product or whatever. And unless you have the resources and you're willing to take on forking it and maintaining your own fork, you're at their mercy. So another potential problem is open source libraries have this nasty tendency sometimes to just vanish altogether, as we've seen recently, or, you know, version 2 breaks your existing code and the guy says, no problem, just rewrite it, just fix it, or whatever. Standards are different. If something is written down and implemented as a formal standard, you have a commitment that is going to be the same. It's going to be available for not just months, but for years, 10 years, 15 years, whatever, and will be compatible. The main thing the standards give you is the possibility of creating multiple implementations. If you don't have a standard, that's really not possible. And here's an example. Facebook, about 18 months or so ago, they do a lot of PHP code. They decided that the Zen runtime framework thing was not efficient enough for them. It didn't scale to their needs. So they said, no problem, we'll just write our own. And then they said, well, wait a minute, we don't know how to do that because there's no formal definition of the PHP language and how a PHP runtime should behave. There is an existence example. There's this thing over here, but we don't know whether what it does is what it does because that's what it should do, or whether it's what it does because the guys who wrote it decided that's the way they would do it, or what it does because it is in fact buggy and doesn't do what they intended to do. So the Facebook guys said, and in 2014 in OSCON, they said, well, we got to start somewhere. We're going to start with a formal specification for the language itself. And only when you have that specification, then does it become possible to actually have more than one implementation. And big users in the real world always want a choice of implementation. They don't want to be locked in, vendor lock-in. They don't want to have to buy all their stuff from one supplier. When I started in the business, before many of you were born probably, if you bought a piece of hardware from IBM, that's it. They owned you for life. You had to buy all the rest of your hardware from IBM, or your peripherals from IBM. You had to buy your damn cables from IBM. You had to buy your documentation from IBM. You had to buy your software from IBM. You had to buy your consulting and your training from them because it was all proprietary. These days, no, right? I mean, this is a IBM or now Lenovo machine, but you know, I can dump that and replace it with an HP machine, or I can take peripherals designed for one type of machine and plug them into another, and it all works. We have a choice, and we only have a choice because standards have been defined, and therefore there is at least a chance of mixing and matching components, whether they be hardware components or software components, so that I'm not locked into buying from one vendor. So as I said, you're building industrial strength systems. You know, you're running kind of global physical distribution systems like FedEx or an airline system or ATM network, or putting missiles into space, or global telecommunication networks. These guys don't like to buy proprietary stuff. They don't want to be at the mercy of Oracle or IBM or HP or whatever. They want at least the possibility. I mean, yes, in practice, you know, once you become a customer of one of these big vendors, it's not easy to switch, but at least in theory it is possible. And at least you can switch and mix and match some pieces. You can only do that if you have multiple implementations, and you can only have multiple implementations if you have standards. Open source and open standards are not kind of contradictory. They don't conflict with each other. They're actually very complementary. If you're creating an open standard and you do an implementation in open source, that's a really good thing, because a lot of people are going to use that implementation. Therefore, your standard will have a better chance of being adopted. And a very effective way to develop standards, rather than going into a room with a blank sheet of paper and saying, I'm going to invent something new, is actually to work on something collaboratively through an open source project. Figure out what works and what doesn't, what people want, what they don't want. Have at least one, preferably 2 or 3 different implementations. And then a year or 2 down the road, when you say, okay, now we're getting some sense of how we want to do X, then you can think about standards. So they work very well together. Okay, so where does Java come from? Where does Windows come from? Windows is whatever Microsoft says it is, right? Unless you're a multi-billion-dollar company, in which case they may consult with you a little bit, ask you for some input. But for the rest of us, it's like it comes down from heaven, you know? So look at Windows 8, what a disaster, you know, that was, because the guys at Microsoft decided they were going to do something wacky, and we just had to live with it. Java doesn't work that way. Java's developed collaboratively through the Java process, through my organization. We're more than 15 years old now. We're about 17 years old. And it is a collaborative, community-based way of developing technologies. So Java specifications we call JSRs, Java specification request, and they're developed collaboratively through a formal open process which is similar to the process used by other standard setting organizations. Anybody who's a member of the JCP can participate. And back to my point, this is not a matter of something coming down from on high. It's not just Oracle that decides. Oracle is a really fierce competitor, HP, IBM, Red Hat. All these guys are part of the JCP, and they work together with us, with Oracle, with other people, to develop Java, because it's in their interest to do so. You know what I was saying about the telephones? If we collectively get together and we build the base on which we can then compete, we create a much larger market, and everybody wins. My first job, or my second job, was at a company where we ported Unix to different manufacturer systems. This was in the days when there were all these mini computer companies, Data General, can't even remember the names of them now, Prime, HP was there. Everybody wanted to have their own operating system. It's crazy, think about it, but at the time, that's what they did. Now, the notion of writing your own and maintaining your own operating system is absolutely insane, right? I mean, how many operating systems are there in the world? Maybe 3, 4. And the biggest and most widely used is Linux, where a whole bunch of people have said, no sense for us to write our own. We'll just contribute to this, and collectively we will build one operating system, and it'll be better than any of us could do separately, and then we can get on competing on other stuff. So, our competitors, Oracle's competitors, I should say. I don't like to say our. I like to use the third party sense. Oracle does this, they. But we also have people from the open source, the developer communities, such as Eclipse Foundation, Java user groups. We all get together and we define, you don't have to go into the details, the point is there's 3 main platforms, Java SE, Java ME for small and embedded devices, Java EE for servers, and they all contain, components, chunks of technology, and the interfaces between these technologies, more specifically the APIs, how you invoke these components to do something, is all formally specified through the JCP. So typically there is there's a JSR for each of these components. And basically a JSR is just a single version of a Java specification. It's going to be led by somebody from the organization, and somebody who's a member of the JCP. I say somebody, but typically this is an organization. It's not an easy thing to do, to be the spec lead, to take charge of the whole process of defining a new version of a specification, and it's typically way beyond the capabilities of an individual. We have had a couple of cases of individuals who have successfully led JSRs. The most recent, most prominent, probably the date and time API, which is in Java 8, was led by Stephen Colborn, an individual who had originally created an open source library called Joda Time. And he decided, crazy, didn't know what he was getting himself into, that he wanted to formally standardize this through the JCP. It cost him 3 years of his life, cost him most of his hair. And in the end, he really couldn't complete it until Oracle stepped in and helped out, took on a kind of joint spec role. But also members of the community, Java user groups who helped. So it's very difficult for an individual to do. But individuals can certainly help, and we'll talk about that later. So the spec lead will gather a bunch of people to help. Again, members of the JCP, and collectively they're called the expert group. Other standards organizations might call them a tech committee or a working group, basically the same. And together they have to deliver not just the specification, but 2 other things too. A reference implementation, which we call RI, and a technology compatibility kit, or a TCK. So specification, you understand, that is, it's a written formal document that says how something should work. Reference implementation is a implementation of that specification, and by our rules, it must be complete. So basically, creating the reference implementation is a way of validating that the specification can be implemented. And in the process of doing the implementation, you may find ambiguities in the spec, bugs in the spec, and say, I don't understand how I'm supposed to do this. You haven't told me. And that can get fixed. The TCK, most people would call this a conformance test suite. It's a set of tests that can be used to verify that an implementation meets the requirements called out in the specification. In the process of building that, you will find bugs in the reference implementation. Again, you'll find bugs in the spec, as you probably know. You try to write unit tests for something. You may say, well, wait a minute, I don't know how to write this unit test because I don't know how that something is supposed to behave under these conditions. So you will disambiguate the spec in the process of writing your tests. And then running the tests, of course, you will find bugs in the spec and you will find bugs in the reference implementation. So they all help each other. But all three things have got to be delivered as part of our process. And conformance, TCK, technology compatibility kit. I didn't invent that name, it's terrible. But conformance is critical and central to our process. So an implementation of standard conforms to it, or it meets all of the requirements that are called out in the spec. We use a performance test suite to verify this. A spec, you understand, one way of looking at it is like a rule book, like a law, set of laws, a formal definition of how something should be. Or you can think of it as a blueprint, a description, something from which you can build something. So this blueprint is for a helicopter, and it doesn't actually show it, but if you drill down into my blueprint here, it will tell you that what we need to make this thing go up in the air is an anti-gravity machine. So if I give you a blueprint that says you need to put an anti-gravity machine inside this thing and then it will fly, well, guess what? You're not going to be able to build that thing because it's not possible to make an anti-gravity machine. So without a conformance test suite, you've no idea whether really you actually have something that works. So certification, a formal process for verifying that something meets the requirements, is central to the whole process. So we call that compatibility testing, and we take it very, very seriously. We say that all implementations of Java technologies must meet a set of requirements called out in the spec. And when we were at Sun, I was responsible for releasing this, and we took it very, very seriously. We have very detailed rules, not just what's written in the spec. We had a bunch of additional rules that say you're not conformant unless you do this, 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 this. But if you meet all those rules, then like a silversmith hallmark that says something has a standard quality, we have our similar quality brand. And we say, this is Java. You can only call it Java if it meets all these requirements. So this is how we're set up. I'm the chairperson. There's an executive committee, which is like the board of directors. I have a small administrative staff called the Program Management Office. They take care of looking after the website. Liaising with each of these represents an expert group led by a spec lead who are working on JSRs. And PMO helps them with working their way through the process and post their materials on the website and manages the voting process whereby we elect the executive committee and so on and so on. And the members can participate by helping in the development of specifications, providing feedback, and they get to vote on to the executive committee. So this just says in words what I just showed in pictures. So I can skip that. Executive committee, board of directors, has two roles. One is to review JSRs as they work their way through the process and their votes at various stages. And the second is to define excuse me, how the organization itself should function and to make decisions about changes we might want to introduce. Sorry. We publish all of we meet about once a month by phone, 3 times a year we meet face to face. We were in Berlin just a few weeks ago. We publish all our meeting minutes and materials at this URL, which you can get to from the jcp.org website. We hold 2 public teleconferences each year. In fact, the next meeting, which is going to be next week, next Tuesday, the second half of it, the second hour of our 2-hour meeting will be a public meeting. So if you guys are interested, you'll be able to actually call in and listen to what we're talking about. We also have a public face-to-face meeting, which usually we hold at Java 1 in San Francisco because it's the best way of getting everybody together at the same time. We do have a public mailing list for feedback, but nobody ever uses it. So these are the current members of the executive committee. We got a mixture of really big vendors. There's HP, that's Hewlett Packard Enterprises. HP split recently, that's the enterprise portion, printer portion. IBM, Intel. So these are guys who actually ship their own versions of Java. Then we have people who use Java. ARM ships VMs. No, excuse me. ARM has helped to create versions of VMs for their hardware. Apple ships their own VMs. But Credit Suisse, Ericsson, Twitter are big users of Java. So we want to have all members of the Java ecosystem represented. We have a couple of individuals, Kyle and Peter Magnuson. We have a couple of Java user groups, London Java Community and So Java. We have Red Hat from the open source world. We have Clips Foundation. We have 2 or 3 guys who work in kind of embedded space, XP, B2Com, and so on. So we try to make this representative of the whole Java system. As for membership, anybody can join, no fees. We're over 900 right now. As I said, we've probably processed 30 to 50 new membership agreements in the last few weeks. We do expect a significant increase as a result of changes we've just made, which we're already beginning to see. About 3/4 of all our members are individuals, and about 16% are corporations. But that doesn't mean that there are 3 or 4 times as many individuals in terms of the amount of work done as there are corporations, because anybody who's an employee of a corporate member can participate. So IBM probably has 30, 40, 50 people working on various JSR. So you can see the numbers here. So if somebody's working on JSR, about 107 are individuals to about 274. So it's like 3 to 1. Then we have a number of nonprofits. Most of them are Java users. Geographically, we're getting better. We used to be 50% North America. Now we're 40% North America. It's good. About 40% Europe, East Africa, which is also pretty good. 6% South America. Asia is underrepresented. We're trying hard to recruit more people in China. And it's a slow process, but we're getting it. Okay, I talked about how we have a formal process. I'm not going to go through the details. It's all written down in what we call our process document, but basically there's a submission process where somebody writes down, this is what we plan to do. We think there is a need for a set of APIs to define whatever. And we publish that, people provide comments and feedback, the executive committee votes and says either, yeah, it's a great idea, go with it, or no, it's a dumb idea, don't. They don't very often say no, but they say no just often enough to make me confident that the process works. Occasionally they'll say, let me give an example. A year or 2 back, somebody said, we want to define a set of APIs that will allow you to program to all of the social media sites, Facebook and Twitter and whatever. And the executive committee looked at this and said, you're crazy. That should changes too fast. It's too immature. The idea that you can actually create something that will be stable over time, that will allow you to do what you think you can do, it just isn't going to work. So sorry, don't do it. So you go through a drafting process when you have something reasonably, not complete, but well on the way. You go through a public review where it gets formally posted on the website, and people can review it and provide feedback. There's another vote at that stage. More development work, fine-tuning when you're done and you finish not just the spec, but the RI, reference implementation, TCK. We have another vote saying, okay, you're done. And then we go into a maintenance phase. So all of this is defined in this process document. Remember I said the executive committee has two jobs. First one is to get involved in this process, and they vote here, here, here. But the second job is to define how the organization itself will function. And you can think of that as rewriting or changing the constitution. We have a constitution. We have actually two documents. One is the legal agreement that you sign when you join the organization. You need to change the slide, as I'll say later. We now have more than one type of legal agreement, but for the sake of argument, let's just assume it's one. The document you sign when you join makes certain commitments, particularly with regard to intellectual property rights and so on. And that is a very complicated legal document. It's 12 pages long, and you won't understand it. I don't understand it. Lawyers don't understand it. You can have two lawyers and give them this document, and they won't agree on what a particular paragraph is. It's really complicated. Process document is the one that defines this. And that's legalistic in that it has to be precise because it is a specification, but at least humans can understand. At least I hope so, because I wrote the latest version, the previous version, and the previous version. But that defines the process of going through like this, and also the governance of the JCP, how we're structured, how many executive committee members there are, how the election process works, and so on. Both of these, of course, are public documents, because as I said, an open standard, if you're not doing things out in the open, it means that the way you operate is publicly documented. So how do we change the Constitution? That simply means changing one of these documents. And if you think about it, these are the specification for the organization itself. And guess what? We have a process for defining new versions of specification. It's the JSR process itself. So we use that same process to modify these documents. We file a JSR. I act as the spec lead. The executive committee acts as the expert group, and we go through that same process. We publish drafts, we have votes, blah. And we've been working over the last several years on a number of JSRs. Collectively, we call them JCP.next. The goal is to reform what we do and how we do it, with the goal of making ourselves as open and transparent as possible, making it as easy as possible for people to participate in the work that we do. Remember I said this is all about intellectual property. You may think, copyrights are nonsense and we shouldn't have copyrights on software and so on. And in fact, the US is much stricter about this than Europe. But it is important to know that when somebody contributes something to a collective endeavor, ideas, that they have the right to do that. They're not just stealing those from someone else, that somebody doesn't own it, so that later on you accept this stuff, you give me an idea, we incorporate it into a JSR, it eventually makes it into the Java platform, whatever, and then 2 years from now, somebody from some company, wherever, perhaps, comes along and says, I own that thing. Alex didn't have the right to contribute to it. Well, then we're in big trouble, right? Because then these guys are going to be charging royalties to it. So we want to make sure that people have the right to use the stuff that we say. Okay, so these JCP.next JSRs, I'm just going to talk about a couple of them. The first one, JSR 348. This is how people used to think of expert groups 5 years or so back. A bunch of secretive old geezers that get together, closed room, and they did even then have an obligation to publish stuff at those various stages. But everything else could be secret, and in many cases it was. So while you would see the end result, you would have no idea why they made the choices that they made. Why did they choose to define something in this way rather than that? You had no insight into what they were doing. We said that's obviously wrong. So let's define some simple rules to make sure that people can understand what's going on. They must do their work out in the open. They must have a public mailing list that people can subscribe to. They must have a public issue tracker that people can read and also log issues. They must be obligated to respond to feedback from the public. And basically, whatever they do, they must make it possible for people to see and to comment on what they're working on. So we've worked this through about 6 months in 2011, and it was a great success. We had a significant increase in participation after that, as individual developers in particular said, well, now I can see what's going on. This is good. And in fact, Java user groups got very enthusiastic, and they created something called the JSR program, which I'll talk about in a while. Second of these JSRs, 364, we finished this just a few weeks ago. And the goal of this one was to broaden and make it easier for people to join. We created a new membership class for individuals with a much simpler membership agreement. Remember I said the JSPA was 12 pages of legal document that even lawyers don't understand. So until we introduced this change, if you as an individual wanted to join, you would have to sign the document. Practice, people just signed it, said an individual is going to sue me, but you really shouldn't sign a 12-page legal document without understanding what you're signing. And like I said, good luck in finding someone who can explain it to you. The new agreement's much simpler. It's much more like a contribution agreement you would sign if you join any open source project. And more importantly, you don't need a lawyer, as you could probably understand it yourself, and you don't need approval from your employer. In the previous case, you did. And that's primarily because in the US, if you're employed, typically your employer claims that they own what's in your head. Even stuff that you do at the weekend, at your own time, your own hardware, in theory, in many employment contracts in the US, the employer owns it. So in order to allow individuals to join, we had to have them go to their employer, and the employer say, to the extent that I may claim ownership of what's in this person's head, I permit them to donate ideas to the JCP. So that's gone away. You don't need to get your employer's permission. And a really important benefit introduced with this is you get formal recognitions having contributed to a JSR. Before this, the only way you could do that was to be a member of an expert group. And that's a tough thing to do. First of all, it's a fairly significant time commitment. More importantly, you actually, we call it expert group for a reason. You actually have to be an expert. You have to know quite a lot about a particular technology. You probably have to be a world recognized expert in this technology, or else be a representative of an organization, a company, or whatever that has a significant interest in this technology. So somebody who is a young developer who is enthusiastic and trying to learn, trying to help, no chance of getting on an expert, typically. But now you have other ways to contribute, and if you make even a small contribution, but one that the spec lead thinks is useful, then you get your name formally on the JSR, on the website, as having contributed to this JSR. And that's good for your career. Think about it. So two people go in for a job, and the interviewer says, I need you to know about this particular Java technology. They will say, oh yeah, I know about that. One of them says, not only do I know about it, I actually helped to define it. And if you go to jcp.org and look up the JSR, you will see my name there. Well, which one would you have? It's a no-brainer. We also introduced a new membership class for user groups. Previously, there was only the JSPA. Most user groups are not legal. You have no legal existence, right? You're just a bunch of interested people. So for you to sign the JSPA in the name of a bunch of individuals who have no legal existence makes sense, right? That's the way we've done it for years. But we said that's silly. So we introduced a partner membership class, much simpler. It's a very simple agreement. In fact, I said to the lawyers, I said, I just want you to give me one paragraph. It should say, we love you, you love us, and we both want to work together to make Java better. End of story. Lawyers have no sense of humor. They didn't do that. But that was what I wanted. But basically, that's what the agreement says. And specifically, it makes no IP commitments. Okay, so there's nothing in there about donations you may make. So the result is that, in fact, as I'll say later, individuals who are members of the user group actually want to contribute will have to get their own individual membership. But this is the membership class that you guys just took out just 2 hours ago. I signed. Electronic submission works really well. Thank you, Adobe. We used to charge corporations, we don't anymore. And like I said, we finished this just a couple of months ago, and it's now in effect. So, a little more detail. So if you're an individual developer, you're a member of Java user group or whatever, you can join as an associate member. You don't need a lawyer. You don't need your employer's permission. You get this recognition as a contributor. And there are 2 seats on the executive committee that kind of set aside for the associate members. They get to vote for them, get to choose them, and the other more corporate members don't get involved in that. So the idea is there'll be a couple of members on the executive committee. This will be introduced in this year's elections, whose job it is to represent the interests of the individuals. Individuals can still join as a full member, but if they do, not only do they need their employer's permission, but we're going further, because previously we found that there were small corporations typically not willing to pay our fees, so they would go to their employees and say, why don't you sign up as an individual, JCP, and then you can go look after our interests and promote whatever. And the effect of that was these people were acting as the representatives of that employer, but the employer was making no IP commitment. So we closed that gap. So if you're employed now, your employer must sign a contribution. Obviously, if 7 people from one company each want to join, the employer has to keep signing these damn things. Hopefully, they will eventually realize, why don't we just join as an organization, as the corporation, and then all the employees would be able to act as their representatives without any further paper. Otherwise, you will have to sign if you're not employed, still sign the JSPA, right? But like I say, you shouldn't do that. User groups, okay, I talked about this already. So partner membership, much simpler than it used to be, but because it has nothing to do with IP commitments, because a non-entity, an organization that doesn't exist legally, cannot IP commitments. So people who are members of the user group should join in their own right, probably as associate members. And for organizations, corporations, and any non-profits that are legal entities can, of course, join as full members. And all fees are waived. We used to charge $5,000 a year for corporations, gone. And any employee of a member organization can participate as representing the organization. And we have this online membership processing, which works really well. And they say it will process 40 or 50 in a few weeks. Oops, that's a duplicate slide. Okay, so all this means is we're trying to really make this a community organization. We're making it easy for people to observe and to participate and to join. So people care about Java and where it's going. No excuse not to get involved. That's what I encourage you to do. Why would you do that? Why do corporations join, Crystal? Well, typically they want to influence technologies that affect their business. They don't want something kind of coming down from on high and suddenly making one of their products irrelevant or forcing them to change a product because they have to meet a new standard or whatever. They don't want to be caught by surprise. So they want to actually have some influence, or at least see what's going on. Often also because rather than everybody doing their own thing, as I said, it's often better, more effective for people to collaborate on stuff and then compete on other stuff. It can be a very good way of providing growth opportunities for employees. Most big corporations have various kinds of training opportunities and so on. They're always interested in making their employees, growing them, making them more technically competent, and then keeping them. Participation, allowing them the opportunity to participate in international standards development. It's kind of both those goals. People grow technically, and it's actually, it's a benefit. For individuals, yes, you can feel good about what you do, but that's not the reason I'm asking you to do it. You can do it because it's good experience. You can do it because it will bring you fame, fortune. How to participate? In the old days, I've been doing this around 10 years now. When I started, I used to go out to developer conferences and stuff and encourage people to join, and they did. And then they'd say, okay, now what? Like I said, unless you were a real world-class expert, you couldn't get on an expert group. So there was nothing for people to do. They felt intimidated. I'm just one guy. You know, what am I going to do? Go up to this big expert group of people from IBM, Motorola, Fujitsu, whatever, and say, I want to help you guys? No. So then we realized, okay, if you work as part of a team, then that's a different matter. So you work through a user group, through school, college, university, or through an employer. And that way you have a number of people collectively can help each other, teach each other, and work together. And there's lots of things to do, which we'll talk about later, no matter what level of skill you have. So this slide is already out of date because it doesn't include Bucharest. It doesn't include Senegal, who I signed up yesterday. We had a bunch of guys from Africa at our conference, and Senegalese buddy of mine, and I said, no excuse. He said, it's now dead easy to join. And while we were in the meeting, when I was saying this, he emailed his buddy back in Senegal. The buddy did the online thing, and by the next morning, I was able to say, okay, you are now the latest member of the JCP. He's already been superseded by you guys. So we were about 50. We're now at 50 some. I'm aiming to reach 100. Really ought not to be. Well, Istanbul joined also. As a result, we visited them a few weeks ago. Now we have this partner agreement, and now we have the online sign up. There's really no reason for any user group. Java user group is actually real and exists, not to join. So my goal is to sign all of them. As I've said, we've got 2 user groups on the executive committee. So Java from Brazil, one of the largest user groups in the world. How many members do you have? You know how many he has? 45,000. Bruno claims to be the first individual who ever joined the JCP and who paid money. Back, I guess, 10, 15 years ago, it seems we charged money. Bruno paid. And London Java community. They have about 5,000 members based in London, mostly in the finance industry and so on. And these guys together have made really significant contributions, primarily by creating and defining this thing called adopt.jsr. You can look it up here. But basically, it is, why did they do this, first of all? Okay, they wanted to get involved and define how Java would evolve. They thought they might make it a little more efficient or faster. But this was really important to them. They looked at existing APIs, and some of them they said, these are rubbish. You know, if you talk to any normal human developed person and said, okay, how does this API look to you? The developer would say, it's crazy, I can't use it. But we didn't have any kind of focus in those days. So they said, we want to make sure that we look at stuff while it's being developed and make sure that it actually meets our needs as just day-to-day developers. They said, we don't want to stand on the sidelines and complain about EJBs, for example. Oh, terrible design. You know, you can stand on the sidelines and you can throw rocks, or you can say, okay, I'm going to be a bit more constructive and I will participate. And they wanted to get involved, to learn new stuff, to make sure that the standards are practical and relevant in the real world, and to make sure that things are truly global. We need input from not just from people in North America, but participating is good for the user group. You get it. You build up the reputation of the user group. Big vendors and local companies will see you're actually doing something really constructive. You will learn actually some disciplines in terms of professional, make you more efficient and effective. Hopefully you will get additional members because people see this as a way for me to participate and begin to build a global reputation for yourself. And you get to work with a bunch of other jugs all over the world. And it's fun. So we have this, it really is an international process. We've had about 30 Java user groups, which is underestimated right now, over the last few years, from all over the world. South America, Brazil, Mexico, North America, Europe, Belgium, Spain, Germany, Istanbul, Indonesia, India, Egypt, Morocco, South Africa, Uganda. So these are all user groups that have actually made concrete contributions to Java for the last few years. And as I said, I don't ask you to do this out of charity. Do it because it's good, because it's in your own interest to do so. To bring fame and fortune. It'll help you in your career. First, the most obvious thing, you grow your network. You know, why do people come to meetings like this? Because they think it's a good idea to know other people, to help you when you're out looking for a job, help something or whatever. So you make new contacts. But more importantly, you will also learn technical stuff. You know, it's a process of participating. But soft skills is what human resource people who are interviewing call things like verbal and written communication. I assume you're all smart technical people. I've been hiring people in the IT business for 2 years. Typically, people don't get into an interview unless they have base technical knowledge. You take that for granted. But on top of that, particularly if you want to advance beyond kind of low, medium level programmer type positions into more responsible positions, whether they be organizational management or architecture, leadership, or whatever, then you need all these other skills. You need to be able to communicate effectively with other people, verbally and writing. You need to know how to negotiate, how to collaborate, how to work as part of a team. And those skills are exactly the kind of skills you learn if you participate in any kind of collaborative process. We were talking just when we were having coffee. You were saying we're trying to set up some kind of organization to help train students, because students don't learn this kind of stuff, right? They learn to program. In fact, I have an example of that. I remember 15 years ago, I used to be responsible for a group that wrote device drivers for Unix or Solaris or Intel machines. And I had this woman. She was an Asian woman. She was a PhD. She had a PhD in networking. I thought, well, damn, I need someone to write network drivers. You know, how could you? This is perfect. Sure, she knew theoretical stuff. She was hopeless at the rest of this stuff. She never worked as part of a team. She had no concept of all the other stuff that goes with building real software. So those are the skills that you learn when you participate in any kind of collaborative activity. It doesn't have to be JCP, any kind of standards organization, any kind of open source organization. You have to do stuff collaboratively with others, and you learn all of this stuff. And if you have done this for a little while, then by all means, stick it on your resume, CV, and when you go for a job, it will really count. People look for that kind of stuff. So, do it. It'll make you rich, not because make you feel, oh, it will make you feel. And you don't have to be a super technical expert to get started. There are some relatively simple but useful things you can do. You can help to moderate mailing lists. You can do a little bit of evangelizing, you know, blogging, whatever. Small presentations. Maybe later you can build that up into something bigger, so that we may get an invitation to days Bucharest next year, you know, and you will actually have the confidence to stand up there and talk about a particular technology that you've been studying. So all good for your career. You can help with documentation, you might help translations into a local language, you can maintain an FAQ, you could work on project infrastructure. See, none of these require you to be a super heavy-duty technical. But if you have more expertise, then yeah, you can get deeper. You can help with managing issues, reproducing problems, setting priorities. You can provide feedback on a specification. You can take some existing software or write some new little program to test out new APIs to see how they work in the real world. And you do that before they're finished so that you learn whether the stuff is actually practical and useful. Give the feedback to the expert. And we did have, you know, this long list. Some of these guys, Chennai. Chennai guys, I forget what the JSR was, something in EE7. But this was a new communication technology, and they said, okay, this sounds interesting, maybe WebSockets. And so they wrote a little, I don't want to call it a toy program, but a test program. It's an interactive distributed network tic-tac-toe game. but they use the new API to actually do communication. And they learned about it, and the Oracle folks said, well, that's really useful. They actually put that test program into the software development kit of Java EE as an introduction to people as to how to use this new API, because it was small and interesting and understandable. So, you know, you can go further. So you test out stuff. You may even actually help to develop the test suite, and you may even help with development. So you can go all the way from something very simple, like just helping create cubes, all the way up to actually helping to develop the thing itself. And in fact, remember I talked about the date time API. Stephen could not have finished that without the help of people in the London Java community who helped him write the TCK, Performance Test Suite, for that JSR. So, and if you're more interested in the platform and the implementation rather than the specification of it, you can get involved in OpenJDK, which is actually do the reference implementation for Java C. So, I've been, like I said, 35 years in the business. I don't know if Java's going to last till the 21st century, but it's certainly going to last 35 or 40 or 50 years. I mean, for the length of your careers, Java JVM is going to be around. What it's going to look like when you're as old as I am is up to you, if you're interested. You can help to define how Java evolves over the next 10, 15, 20 years or whatever. So that's it. I encourage you to get involved in any way that you can, because A, it's fun, and B, it's good for your career. Okay, I'm done. If you have any questions, I'll be happy to answer. No questions.
So thank you, Patrick, for us and inviting us to get the development community.
Okay. Thank you.
If we would want to get started with this, what would be some, I don't know, 3 steps, 4 steps for us?
If you just Google adopt a JSR, and they have a wiki that has, okay, how to get started. And here are some things to do. And here are some guidelines and so on. The other thing that you should know is there is a user group mailing list. I don't know if you guys are on it, but if you're not, you should be. So you can talk to other user groups who have done this kind of thing and get some practical advice from them. But start by Googling adopt a JSR and read the wiki, and you'll find some practical information and advice there.
We have a Slack channel, so you can join there, and Aline will help you. We had an initiative the past year to adopt the GSR, but we don't find the people to adopt the GSR.
Mm-hmm.
So
okay.
you just join the channel, and me and Aline will help you through the process.
Okay. Do you have a question?
How is this usually received? I mean, I saw a lot of Java groups that are here and there, and it's not in everyone's. The first response is not to help others; it's just to help yourself. So I'm wondering overall how much people get involved after speech like that.
Well, I think the fact that somebody joins a Java user group, takes the trouble to join in the first place, means that they've taken the first step. Like I said, you know, I don't know what time it is now, you're giving up your evening, right? Why? And the football, yes, right. So why are you here? Okay. So you want to learn something? Yeah, okay. So, like I said, that's why I try to emphasize that, you know, you get something out of this, okay? It really is, I mean, you all want to get on with your careers, right? And believe me, if you want to be more than just a smart person who sits in a cubicle and codes, you know, first point to make is developing real software systems. Coding is like a tiny portion of what gets done, right? There's the design, there's the implementation, there's the testing process, integration, there's all of this stuff that goes on. I started out as a programmer myself. I've done, with the exception of leading a documentation team, I've done all of the other stuff. And the group that was responsible for testing stuff, the group responsible for doing integration, as we used to call it in those days. Today, talk in terms of DevOps or whatever. But all of these are skills that you need to learn in your career, and you may not have the opportunity to learn all of them in the particular job that you're working in at a particular time, right? You may be actually, in fact, the London Java community guys tell me, you know, a lot of their members, they have people, they're working in the finance industry. So they're working for some big bank. And you can bet, you know, they're probably not given an enormous amount of responsibility, you know what I mean? They're not designing something big and significant. They're just a tiny little cog in some big machine. And many of their members join the London Java community or participate in some kind of collaborative, open sourcey kind of project, precisely because they get to stretch muscles that otherwise they wouldn't get to use. They get to learn stuff and gain experience that they otherwise wouldn't get. I have another flavor of this presentation that focuses much more on the career thing. That's what I'm going to be doing in Brazil in 2 weeks. But basically what I say is, okay, I've been 35 years in business. When I started, okay, there were no PCs. Well, they were just coming in. I started with punch cards. There was no networking, there was no internet, no cell phone, no nothing. Couldn't possibly then predict the world that we live in today, right? The fact that everybody would be, okay. When I started, it would cost you, I think, a Cray supercomputer, you know, those things about this big, they were round. They had these like this leatherette seat thing, very strange machine. They cost about $2 million. This is more powerful than that thing. So we had no idea then that we would carry around in our pockets a supercomputer. And that these supercomputers would be talking to each other all the time, and that we would have all of these amazing capabilities with online translation, blah, 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 blah. So how do you plan a career? You can't, right? What are you going to be doing 20 years' time? No idea, right? All you can do is position yourself in such a way that you're able to take advantage of opportunities when they present themselves. That's all I did. I actually, by the way, I never studied computer science. I started out doing a PhD in economic history, and for various reasons I got diverted and ended up, you know, where I am. But at each stage where I ended up with a new job, it was like just something came along and I just grabbed it. The metaphor I use is kind of like surfing. You know, I'm not a surfer, by the way. I live in Southern California. But you see, okay, so you've got to go out there and the waves are coming in. You've got to position yourself so you're ready to hop onto a wave when it looks right. It's not so big, it's going to crush you. It's not so small that you're just not going to get anywhere. Well, job opportunities are sort of similar. So how do you maximize your possibilities, maximize the chance that when an opportunity comes along, you will actually be able to take advantage of it because you will have the kind of skills that the employer is looking for. You can really only do that if you're very lucky. You know, you may actually get to learn a whole bunch of stuff in the job that you're working in. But most of us don't have that opportunity. Just need to doing whatever. And you gain some expertise in this technology. But that's not what employers are looking for anymore, right? They want you to know a bunch of stuff. And more importantly, they want you to be able to show them that you can learn new stuff. Because whatever we're doing today, we're going to be doing something completely different 3 years from now. I don't want to hire you if you're an expert in what we do today, if when 3 years from now we're going to be doing something differently and you are completely incapable of adapting to that. So how are you going to show me that you can adapt to that? You can show me by saying, I've done this, and I've done this, and I've done this. I've worked in this open source community. You find my name on that library over there. I helped with this specification. And as you build your way up through this, I actually have a global reputation. You know, there are people in the US, I live here in Bucharest, but there are people in the US who know my name because I have participated in this kind of stuff. So yeah, want to sit in the cubicle for the next 30 years, that's fine. Do it. You don't have to do any of this stuff, and you get to go home at 5 o'clock in the afternoon, or whatever, watch TV. But if you are a little more ambitious, as I'm sure you are, wouldn't be here, then get out, do something. And it doesn't have to be the JCP, it doesn't have to be standards. Open source is good. In the US, I think, well, I know, as I read about it, you know, when kids are trying to get into college these days, they don't just have to have, you know, good grades. They have to be able to show that they've done a bunch of other stuff. They go out, they spend years building up a resume. They have to be able to say, oh, I go and I serve, you know, soup to homeless people, or I'm a volunteer at whatever. You can't get in, apparently, to a decent US university these days without at least one, if not 2 or 3 of these non-academic things on your CV. It's just what you have to have in the world today. And the other point I make is, I don't care how smart you are. Somebody else out there who's at least as smart as you are, who will work for less money. Okay. Outsourcing, right? My family comes from Ireland. And 15, 20 years ago, the company I was working for said, oh, we want to do some outsourcing. We're going to go to Ireland. We're going to set up an office in Dublin because they're English speaking, they're well educated, it's well situated time zone wise, they're right there on the edge of Europe. We set up an office in Dublin. It lasted, well, still there, but you know, within 3 or 4 years, they said, well, these Irish cost a bloody fortune. Let's go to, where do we go next? Russia. So then I had a whole bunch of teams. I had a team in Russia, 2 teams in Russia, one in St. Petersburg, one in Siberia. Then the Russians got too expensive, and so we go to India, and then we said, oh, the Indians are too expensive, we're going to go to China. And I don't know where people are going today, although I have a friend in Bulgaria who is getting business outsourcing to maybe Bulgaria is the place to go. Maybe Romania is the place to go today. Oracle has outsourced a whole bunch of stuff to Romania, apparently, the biggest non-native employers. I don't think much of it's technical work, but the point is, you know, you're going to get outsourced sooner or later. So if you don't have all those soft skills and all of that stuff on your CV, you're going to be out of luck. Okay? Long answer. That's a good question.
So basically, if you work in a bank and you're bored, just
right. Okay.
So
very good.
How much time does it take for you to do something, to accomplish something? Okay, you can adopt a standard. What's the volume of time that you need to work to achieve something?
It can be very little. If you wanted to spend even an hour or 2 a week, you know, that would be welcomed by, especially by the expert who could do something useful in that amount of time. It really is, it's scalable. There are some people who put a lot of effort into some of this work, you know, many hours a week, but, you know, everybody knows that not everybody can do that. So it really is up to you. A little time, a lot of time, your choice. Okay? Okay, we're done. Thank you.